Okay, so here's the warm-up. You guys should be working on the 8.3, 8.4 warm-up, and then you'll pause it and turn it back on and we'll go over it, make sure you have everything correct so that it reminds you what we did last week to get ready for your 8.3, 8.4 quiz. Okay, so decide if the quadrilaterals are parallelograms, explain your reasoning. So remember we had 4 or 5 ways to show that you've got a parallelogram. The first one was to show that you have 2 pairs of opposite parallel sides. That's the definition of parallelograms. Then we could show one of its characteristics. If one of its characteristics shows that your opposite sides are congruent, then it's a parallelogram. If opposite angles are congruent, then it's a parallelogram. If diagonals bisect each other, it's a parallelogram. And then the one that was kind of new was if one pair of opposite sides were both parallel and congruent. Okay, so we're proving if these are parallelograms. So number 1, you should have said no, or not a parallelogram, because we don't have any of those 5 things I just showed you. What they're trying to show you is that you have those adjacent congruent sides, so maybe it's a rhombus, but remember we had to know it was a parallelogram first to be able to further say it's a rhombus. So we're just deciding parallelogram as these first ones. So not a parallelogram, and this one is yes, diagonals bisect each other. Okay. All right, now on the second ones, decide if the parallelograms are rectangle, rhombus, square, or none of these. So now we know it's a parallelogram, so it satisfies that piece. Now we're trying to further classify it as a rectangle, rhombus, square, or none of these. So rectangle was if you knew the parallelogram had one right angle, or if you knew that the parallelogram had congruent diagonals, then you could say it's a rectangle. For a rhombus, you could say a parallelogram is a rhombus if you had that situation like on number 1 where the one pair of adjacent sides are congruent. You could say a parallelogram is a rhombus if they said that the diagonals are perpendicular, which is one of the characteristics of a rhombus, or if a parallelogram has diagonals that bisect the angles, then it's a rhombus. And again, that was another characteristic of rhombus we knew already. Then remember to say if a parallelogram is a square, you have to have one marking from a rectangle and one marking for a rhombus. And then if it doesn't have any of those, then you can't say it's a rectangle, rhombus, or square. It's just a parallelogram. Okay? So on number 3, they are showing you that the diagonals are perpendicular. So then this is a rhombus. Don't go off the looks and say, well, it's also a square, because we don't have something else for rectangle to be able to say it's a square. Okay, here we know, again, we already know this is a parallelogram, and so they show one right angle, so that means it's a rectangle. So you really do need to go off the markings, not necessarily what it looks like. Okay, you need to know your definitions for parallelograms, rectangles, rhombuses, and squares, because that helps. And then their characteristics are just showing up again. Okay? All right, so go ahead and clear off your desk except for a pencil, and you don't even need a calculator for these, so just a pencil, no calculators or phones out. Get your dividers, put them up, and as soon as that's ready, then the substitute will pass out the quizzes. Okay, so now you should be done with your quiz, and then the substitute will pass out the section 8.5 Cornell notes to you, and then you will copy this essential question. So this is our last section, 8.5, that we're going to cover. The essential question is, how do you find the length of the mid-segment of a trapezoid? So by the end of today's notes, you should be able to answer the essential question, how do you find the length of the mid-segment of a trapezoid? So you guys can pause as needed. All right. So first main idea is trapezoids. And here's a definition, and draw the picture because there's different parts of a trapezoid that you'll have to know about that I'm going to use this picture to pick out. So the definition of a trapezoid is, again, it's a quadrilateral because we're focusing on four-sided figures with exactly one pair of parallel sides. And they have to be opposite each other because if they're adjacent to each other, they're not parallel because they're touching each other. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. So that's different from a parallelogram, which said you had two pairs of opposite parallel sides. Okay. Bases of the trapezoid, the bases of the trapezoid are the parallel sides. Bases of the trapezoid are the parallel sides. So in my example here, what would that be? Well, it should be segment BC and segment AB. That's how you would name them because remember the sides are represented as segments. Okay, then we have the legs of the trapezoid, and the legs of the trapezoid are your non-parallel sides because if I extended those sides, they would eventually meet. So those are non-parallel sides, and those are your legs. So in my example, that would be segment AB and segment CD. Now, the legs don't have to be congruent to each other. That won't always happen, but the non-parallel sides are called the legs. And then the base angles of a trapezoid, there's two pairs of them. There's two pairs of base angles. Two pairs of angles that touch the bases of the trapezoid. So since there's two bases, there are two pairs of base angles. So since one of our bases was segment BC, then that means angle B and angle C are a pair of base angles. And then since segment AD was one of my bases, then angle A and angle D are a pair of base angles. But angles A and B together are not a pair of base angles, and C and D together are not a pair of base angles. It has to be touching two angles that touch the same base. Then they make a pair of base angles. Okay, so pause is needed. All right, so another one of these graphing ones. So go ahead and pause it, and I want you to try this one. So we're deciding this time if it's a trapezoid or not, and you still have to justify your answer just like we did when we were proving if we had a parallelogram in the coordinate plane or not. So pause it and try it. Okay, so -1, 1, 2, 3, 4 was here, maybe, right? Okay. -2, 1. Now again, we can't just go off of looks because you have to justify your reasoning. So I'm still going to do slope. Slope is the best way to decide if things are parallel or not, okay? So don't do distance formula because that's not going to prove anything about being a trapezoid at all. So I'm going to do slope for AD. I'm just going to count rise over run. So 1, 2, 3 down and 1, 2, 3, 4, 5, 6 over. So -3 over +6 is -1/2. Okay. Now let's do its opposite side, BC. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So down 4 over +8. So that's -1/2. So then we can conclude that these are parallel. You can either just mark it in your picture that way, or you could write out AD, segment AD is parallel to segment BC. That's your conclusion based on the slopes that you found. Okay, now let's do AB. Now, even though you just found one pair of parallels, you can't be finished and say it's a trapezoid because you have to show that there's only one and that the other pair is not also parallel. So AB, go 1, 2, 3, up 1 over 3, so that's 3 over 1 or 3. And then DC is 1, 2, 3, 4, down 4 over 1, so that's -4. So then these are not parallel. So you can either say not parallel or just have a lack of arrows in your picture, either one. Okay, so then we would say it's a trapezoid, and I've got the proof, the algebraic proof above with slopes, knowing that we have exactly one pair of parallels, the others are not. You do have to make sure that you show that there's only one pair. If there were two pairs, if they ended up both coming out to be parallel, then you would say it's a parallelogram. Okay? All right. So I want you to tell me what is the difference between proving a quadrilateral is a parallelogram versus proving a quadrilateral is a trapezoid in the coordinate plane. So do that on that left-hand side blank page of your notes. So pause and do that. All right, so hopefully you said something like, if it's a, because we just talked about it, if it's a parallelogram, then you would say that you show you have two opposite pairs of parallel sides. So you find slope, and then you decide if they're parallel or not. Whereas in the trapezoid, you still do the figure out what's parallel, but for a trapezoid, it would need to just be one pair of sides, one pair of opposite sides that are parallel, and you have to show that the others are not. Okay, so they do have a similarity in that you're finding slope to decide parallel or not, but the difference is trapezoid would just have one pair of parallel sides, parallelogram would have two pairs of parallel sides. Okay. All right, more vocabulary. We have an isosceles trapezoid. An isosceles trapezoid is a trapezoid with congruent legs. So that would look like this. So I have your parallel, so you have exactly one pair of opposite parallel sides, and then you mark the legs congruent to each other. Because a lot of cool things happen when we know it's an isosceles trapezoid. We still have two bases. Segment BC and segment AD are my bases here. Segment AB and segment CD are the legs, and they're congruent, so that's the isosceles part. We still have two pairs of base angles. Angle B and angle C make a pair. Angle A and angle D make a pair. But we've got some characteristics of an isosceles trapezoid that we didn't with a regular trapezoid. And one of them is that the base angles will be congruent to each other. So in my example, more specifically, angle B is going to be congruent to angle C because it's just within a pair. It doesn't mean all four are congruent to each other, because if all four angles were congruent to each other, it would no longer be a trapezoid, it would be a rectangle. But angle B is congruent to angle C, whatever those are, and we would know angle A is congruent to angle D. So both pairs, you've got two sets of congruent angles. And this is one like the rectangle. Remember, the rectangle had diagonals that were congruent? So that's why I said it wasn't enough to know that the diagonals are congruent in just any quadrilateral to say it is a rectangle. You would have to know it's a parallelogram first, then prove it's a rectangle that way. Here, if you've got an isosceles trapezoid, the diagonals would be congruent. So if I drew in the diagonals in my example, then segment BD would be congruent if I drew in the other diagonal, segment AC. Now, I can't even put the single slashes on all four of these because in a trapezoid, we don't know if the diagonals bisect each other, and they actually don't. Okay, so we would just have to say segment BD is congruent to segment AC and not have a way to mark it. Okay. All right, so let's look at example 2 on how you would use that information. The top of a table is drawn below. It is an isosceles trapezoid. So I'm going to add these little pieces in because we know it's isosceles trapezoid. And we want to find all the missing angles. So go ahead and pause it, and I want you to try it with your group and see if you can find those 3 angles. Okay? So remember M and P, those are base angles because they're touching that base. Okay? So then that means the measure of angle P has to be congruent to the measure of angle M, which is 65 degrees. Now remember, it is an isosceles trapezoid, so that means, remember, the bases are parallel. So how did you get angle N? Or how could you get angle N? Well, you've got that C going on, since these are parallel in a trapezoid. So those angles are supplementary, so you should do the 180 minus 65. And what did you get? So we should get 115. And then that's going to be the same as angle O. Now from 8.1, what's the sum of the measures of the angles, the interior angles of a quadrilateral always going to be? Well, remember that was the 180 times n minus 2, and n is 4, so 180 times 4 minus 2. 180 times 2 is 360. So every quadrilateral adds up to 360, so that's another way you could have gone about trying to get n and O. You could add 65 and 65, subtracted that from 360, and then that would have, and if you divide that number by 2, you would have gotten each of the angles. So lots of different ways you could think about it. All right, more vocabulary. Mid-segment of a trapezoid. So this was what was mentioned in the essential question. The mid-segment of a trapezoid is a segment that connects the midpoints, so mid-segment, midpoints, of the legs of the trapezoid. So here's an example. So go ahead and pause it so you can copy all that down, and I'll tell you more about it. All right, so we've got our trapezoid part with the parallel, one pair of parallel sides. But if E is the midpoint of AB, leg AB, which they're showing you with the slashes, remember that's how we mark that. So E is the midpoint of that leg, F is the midpoint of that leg, and we don't know that these legs are congruent. If they were all, if it was isosceles, then we'd just put singles on all four, but we don't know that. And then when you draw in this segment EF, segment EF is the mid-segment of this. And there's only one mid-segment in every trapezoid. Okay. Now there's a cool relationship here. To find the mid-segment length of a trapezoid, you're going to average the two base lengths. So above in my answer here, if I call one of the bases base 1 and one of the bases base 2, so b sub 1 and b sub 2, then I'm going to write this formula. Now, it's not a technical formula, it's just doing what it's saying. But to find the mid-segment, that's going to equal adding the two bases. Remember, average, you divide by how many there are. So to find the mid-segment length, I take two bases and add them together and cut it in half. So that's averaging it. Okay. All right, if you need to pause before we move on, then go ahead and do it. All right, so example 3, we're going to find these missing lengths. Okay. So we said find HA. Now they're giving you these markings here showing you that H is the mid-segment of that leg, A is the mid-segment of that leg, so this is your mid-segment. And remember, to find that, we are going to average the bases and divide the bases, which is inside by 2. So HK equals 6 plus 18 divided by 2. So what is that? 24 divided by 2, which equals 12. So that's your HK, which is the mid-segment. Okay? Part A. Part B, we have two things to find, X and Y, and they're telling us down here without the markings. So they'll either show you the markings like this to show you the mid-segment or just flat out tell you we know that NP is the mid-segment. Now, if I put 12 X on this one, notice the difference from 6 to 12 is plus 6, and the difference from 12 to 18 is plus 6. So 12 plus 6 to get 18. That will always happen because you're finding So that's going to help here when they give you the mid-segment, but you're missing one of the bases. So to get x, notice from here to here, what are we doing? We're adding 3. So you have to do the same here for this to actually be in a mid-segment length there when you average it. So 12 plus 3 means this has to be 15. So there's really not work to be done on that. There's only work if you had a bunch of variables where it was like 3x plus 5 and 2x minus 10 or something like that. Okay? All right. Now, since this is the mid-segment, I can mark this. So that's n is the midpoint there, and p is the midpoint here. So then what should y equal? 3. Since p is the midpoint of this leg, because np is the mid-segment, then those two lengths have to be the same. Okay, so you'll have a couple more practice where they throw in a little bit more variables on your assignment to see if you understand how to do it. It is a book assignment, so you'll try it then. All right, so pause for a moment, and I want you to write us one study question so far that reflects the notes that we've taken. All right, the last main idea are kites. Kites are another special type of quadrilateral. It's the last one we're going to talk about. So we have kites. Well, the definition of a kite is a quadrilateral that has two pairs of consecutive congruent sides, but opposite sides are not congruent. So I've got one pair of adjacent sides or consecutive sides that are congruent. And then if I draw another pair of consecutive sides, so these two sides are touching and they're congruent to each other. But notice that these opposite sides are not congruent to each other. That's that last piece. So all four would not be able to be congruent, because if all four were congruent, then it wouldn't be a kite, it would be a rhombus. So you've got two pairs of consecutive sides that come out to be congruent to each other. That is a kite. Much like the kites that we flew back in the day before they got really cool kites where it's dragons and all that kind of stuff. All right, couple characteristics of a kite. Diagonals are perpendicular. If you draw in the diagonals here, they will form a right angle. So that was why when we were proving if something is a rhombus, you have to know it's a parallelogram first. So once you know it's a parallelogram and you say diagonals are perpendicular, then it was a rhombus. But if you just have a four-sided figure and it says the diagonals are perpendicular, you don't know if it's a kite or if it's a rhombus. If it was just some quadrilateral with perpendicular diagonals. So that's why it was important when we were proving it was a rhombus, you had to know it was a parallelogram first. So diagonal. And then the last one, which is going to help us with some calculations, exactly one pair of opposite angles are congruent. So that's different from a parallelogram because that had two pairs of opposite angles that were congruent. This one, you can only have exactly one pair of opposite sides, and it's where the two non-congruent sides meet. So single double, that meets here, single double, that meets here. So those are the pair of angles that are going to be congruent to each other. That's the only pair that are congruent to each other in a kite. Okay, so then we'll skip that for now. Looking at example 4, we'll do A together and then I'll have you try B. So on example 4, notice they have angles drawn, so that's the one that we care about. They did not draw the diagonal, so I'm not worrying about diagonals perpendicular. So angles are drawn. Which of these angles will be congruent to each other? It's going to be angle M and angle K because those are where the single and the double meet. The single side and the double side meet. So then we know angle K is 88 degrees. So measure of angle K equals 88 because they have to be congruent. Now, how am I going to figure out the measure of angle J? How many degrees does this quadrilateral have to add up to equal? Right, 360, and then subtract off the 88 and the 120. And what does that leave us? 64. So the measure of angle J is 64 degrees. Okay, so you try B. Go ahead and pause it, and I want you to try it, and then we'll come back together. All right, so again, where the single and the double meet, those are the angles that are congruent, so I could call those x degrees. They're going to be the same. So I could set up an equation, 2x plus 60 plus 50 has to add up to equal 360 again, because remember, every quadrilateral adds up to 360 degrees. So 2x plus 110 equals 360. So minus that, 2x equals 250, and we divide by 2 so that we can get both of these angles, which is 125 degrees. So that means measure of angle M is 125 degrees, and the measure of angle K is 125 degrees. Now, you might have done it a little different. Maybe you just did, instead of setting up an equation, you just wrote 360 minus 110, got 250, and then you did 250 divided by 2 to get 125. That's okay too if you didn't have it in this form. Okay. All right, so a lot of information. Now you have some practice time. You already have the review, so you can work on that after you practice the kite stuff from the book assignment. And the book assignment is on OneNote. That's my homework that I do for my college class. Let's see here. Let me pick assignment, chapter 8. Okay. So here is your assignment. It is on your OneNote, so that's your assignment. The book assignment answers should be on Schoology. I can't remember if I put the review assignment on there or not. If not, then we'll talk about it on Tuesday when we have our review day, and then Wednesday will be your test. Okay? Make sure you keep up on your repetitions. Don't wait till the last minute to do those.